Kevin.
Hi, Joe. How you doing?
I'm doing well. How you doing?
Well, I'm doing all right. Can't really complain.
That-
How's it going over
That's
there?
good. That's good. I can't complain. Busy day today, so
All right. All right. All right. Great. 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 Okay, so let's just give our colleagues some time to join.
okay, okay, no problem. I wanted to
Uh,
ask, will you be
sure.
giving us like assignments and projects to work on?
Yeah. So I think there already is a project you guys are expected to perform on the platform. So for every course, there are a couple of projects. I think it's about two or three, depending on the course. So I'm pretty sure there's a project for this course. I think I'll follow up with the team to get that clarity. Then for the assignments, there are also quizzes for every module we complete. So I don't know where that quiz is. If I know we have it, it's supposed to be somewhere on the platform. Probably I would ask after this session, I would ask Chinwe on how you guys can get access to it after this session.
Okay,
That should guide me. Yeah,
okay, okay, okay.
awesome.
Thank you so much.
All right, thanks,
And
Joe.
yeah,
Hi, Collins. Your hands are up. Hi. Good evening. How you doing?
Good evening. Thank you. Okay, and please, there's a couple of things I want to find out.
Sure.
Your website, there's nothing
Mhm.
much on cybersecurity because I'm trying to get to see the curriculum and what we'll be doing, but I'm not seeing much about that. And I don't know if this if it's going to be weekly session or twice or three times.
Okay, so I believe the curriculum should already be there. I don't know, probably maybe they might have to share with you separately. As I said, same thing I told you. I would actually ask this questions you're asking. I'll actually discuss with Chinwe, who is the lead, training lead, on where those things are because I know we have them, right? So, but I know it's there. The curriculum, it's there somewhere. Same as the quizzes and projects are also there somewhere. I'll probably I need to give you a link so that you just go straight into them so you don't get lost. For the sessions here, they are weekly, once a week. Every week we have the session. So the idea, if you look through the Diary.io model, it's called the project-based learning. So what we do is we take you through a program or a certain curriculum with projects. So every course or almost every course has a project, either some hands-on projects or some capstone projects attached to each course. So basically, and each course might take 2 weeks, 3 weeks, depending. So basically, you actually have the opportunity to go through each and every one of them each week. Do you get so it's so basically that's the whole idea, right? So there are going to be projects. So wow, so the live classes are just once a week, taking you through these concepts, making it make sense. Then the projects, are giving you some real life scenarios, and then you try it out and see how it works in your environment, test it, that's how it works, right?
Okay.
Does that answer your
Okay.
question? Yeah.
Yes. Thank you. Thank you. Thank you.
All right, thanks. Okay, I think we can start. I don't know. I think a couple of people might not be here yet. Samuel, hi, how you doing? I think you joined a bit late last class. Um, Ahanon, I hope I pronounced it correctly. How you doing? I don't think I saw you in the last class either. I think I'm missing about two or three people that were in the last class, not here. All right, welcome everyone to today's session. For those that don't know me, my name is Kevin, and I will be your instructor for the day. Um, so I think, for those that haven't seen me before, I'll just turn on my camera, but I won't leave it on for too long, depending. All right, but yeah, this is me, Kevin. For those that don't know me, I'm Kevin Annie, and I'm your instructor through this program. Now, I'm a bit excited about today's session because, the introduction to cybersecurity um, course has two live classes. So this is the second live class, and in this live class, I'll be challenging you guys a bit. So two things are going to have to happen, right? Firstly, I'll try to talk about and discuss and show, if possible, a bit more complicated concepts. So the concepts wouldn't be the straightforward concepts, right? I'll show you a bit more complicated concepts. Then, and then I might also need to move fast. So that's why I said I'm going to challenge you guys a bit. So I'll really appreciate if you guys keep up with me as much as you can. But then I also appreciate interactive sessions. I want you guys to ask questions. I want you guys to really have a feel of what it would look like. As I was mentioning earlier to Joe and Collins, that this is a project-based learning. So these live classes are classes to actually help um, 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 uh, more or less trigger the concepts and the understanding that you get when you do the projects. Because as I mentioned, every course, because we split everything into different courses. So every course in a program has at least one or two projects. Sometimes they have one hands-on project and one capstone project. Sometimes they might have two hands-on projects, one capstone project, but there's always a capstone project, there's always a hands-on project, right? So every course here has some projects. And that project, by the time we talk about the concepts and talk about have the live classes, discuss some of these things, go through the slides, sometimes show you some demo to make it make more sense. Then you then go and do your project, which is trying to attach the real life scenario to all what we've been discussing. It would, in some way, start making sense to you. And then the beauty of it is, at the end of the program, you can boldly say, "Oh, we did projects. We did some projects through the class, right? That made us understand it a bit better and stuff like that, right?" Okay, so today we will basically start off an introduction to virtual machines. Now, this is very important because two reasons. One, through this program, you would be working with virtual machine of some sort, right? So it's always nice to have a virtual machine up and web running because we wouldn't expect you to buy a brand new laptop and install Kali Linux as a base OS. So you have to do it by setting up a virtual machine. And the instructions have been given to you earlier if you follow the project-based learning. The instructions are there, but I might do a quick demo on a virtual machine setup, right here during this session, but then you might be needed to set up a virtual machine, and then basically that's just what we need to do. So setting up a virtual machine, having understanding what virtual machines are. Why do we discuss virtual machines? Then we'll quickly jump into talking about networks. After we round off the network, then we'll round off with introduction to malwares, and that's the end of today's session. And then, all the quizzes for each of those modules will be shared across to you guys, right? Okay, so I'll be sharing my screen. Let me know when you begin to see it. If you have any questions. Yeah, okay. So also, while my screen is coming up, this is the place where you can ask questions. For some of us that were not in the last class, and might, looked at the recording and have a few questions that require some bit of clarity, this is where you can actually ask those questions. So if you have any comments, okay, I think you've dropped the hands. All right, okay. So I guess the questions there. All right. Let's do it. Joe, do you have a question? Okay.
No, the line froze for a little bit.
Oh, okay. Okay, I said I'm trying to get my slides open. So let's see. Okay, yeah. Let me know I can see the screen I'm sharing. Sorry, I think I'm sharing the wrong screen. Yeah. Hello, what's up? Why is the screen not coming up?
Yes, you
Yes.
can see.
So can you please tell me what's on the screen just to be safe? Be sure that yes, everyone's seeing the same thing.
Introduction to cybersecurity course.
All right. Thank you. Yes, that's the screen. Okay, so yeah. All right. So now, as I said, the first thing we'll talk about today is virtualization of virtual machines. Now, I'll do a brief discussion about it, then I'll do a very, very brief demo on what a virtual machine can feel like and can look like. I have different virtual machines on my environment, so it might not be the exact same experience you would have, but just giving you a demonstration of what it looks like, right? And then, then we'll jump into networks and keep on going. Okay, so first of all, we'll talk about understanding virtualization in enterprises. Virtualization is very, very important in enterprises. There's a reason why virtualizations are important in enterprises. They have a work, I want to say they have a work they do, right? But there's a reason behind the importance of enterprises, and I will break it down for us as we go ahead. Right, then we also have virtualization and hypervisors, using different hypervisors and common virtualization configurations. Then threats to virtual machines and securing virtual machines, because this is a cybersecurity program, obviously. We need to talk about what are the threats to these guys we are really raving a whole lot about, right? Great. So firstly, what is virtualization? Now, it is the aspect of creating virtualized resource. Now, that word virtualized resource should, ring a bell in our mind, because I remember last week when we discussed and I tried to break down IT fundamentals to the barest minimum. I kept on mentioning that it's very important to note that these these concepts or these IT environments is also based off of computing resources. So meaning there must be a hardware performing that process. There must be a processor processing those requests. There is a computing activity to it. Now, creating a virtualized resource to do those things is virtualization. So instead of having a hardware that is fully set up and it's fully for one aspect for a certain activity. For example, you can have a computer. Back then, I know we used to have a computer just for typing. We have guys that their own work is their typists. They'll be typing day and night, just typing, right? That's all that was for, right? They would, if they needed another computer for another thing, they would go and buy another computer for someone that is printing. The kind of thing. So it was very rigid and not flexible back then. Right? But virtualization is saying we could actually be creating virtualized resources that can do all multiple tasks. So instead of having one physical resource, you have a virtualized resource, right? So this refers to the creation of virtual rather than physical, virtual representation of computing resources. For example, instead of having a physical server in Naira, it's millions of Naira. In dollars, it's about 10 to 20K dollars, right? A very good server, right? Instead of spending that amount of money and getting servers, instead of spending tens of thousands of dollars to buy storage, I actually know a Nigerian bank that spent about $70,000 just this year to buy a certain amount of storage, right? That's how expensive storage is going to be. Instead of spending so much money setting up your network or your printing systems, you can actually create a virtual representation of those computing resources without getting the hardware, right? Now, this process enables the efficient utilization of your hardware, enhances flexibility, and improves resource management in IT environments. Now, let's look at it this way. Let's think of it this way. I always use this as an example. We have, let's say we have, okay, so let's do some maths, right? And I want you guys to please be with me throughout my calculations, right? I used to like maths back then in school. So we have, let's say we have a physical server, one physical hardware server, right? That hardware server, so who can tell me some of the important metrics or important resources, or what are the things that makes up a good system? What are the important things you need to talk about if you want to buy a good system now? What are the things you ask about? Can someone please tell me?
You asked about the memory.
Okay, that's the RAM, yes. Any other one? Any other
Graphics.
person? Come again, Joe.
Graphics.
Graphics, good. Graphics card, yeah. What about the processor?
Yeah, the processor too.
Exactly. Processor, speed, and core, right? How about the
Yeah.
storage?
Yeah.
Good. Exactly. So processor, speed, core, storage. So RAM, graphics, processor, speed, and core, storage. That's like 5 things, right? So now let's put it this way. Let's say we have so let's say Joe was hired as the head of IT, and when he was hired, he came in and met a server. That's the company that hired him already has a server. The server has about, yes, the operating system, thank you. So the server has about 500, well, yeah, 512 gig RAM, not MB, 512 gigabyte RAM. Okay, please do this math with me. Has a graphics card of about 2 gig, could be more, but let me just say 2 gig. Yeah, no, 2 gig is too small. 8 gig graphic card. Has a processor of about 8 cores. Processor has 8 cores. The speed of the processor, well, can be 2.8 or thereabout, but the number of cores is most important. Has a processor of 8 cores. Or no, let's say 16 cores. Has a processor of 16 cores, right? 2.8 gigahertz. Has a storage of 5 terabytes, right? You can take a look of it. 512 gig RAM, 8 gig graphic, 16 core processor, and 5 TB, 5 terabytes storage, right? That is what this hardware Duo has. Now, this is the trick. Now, Joe actually requires 4 more servers. Now, this server in question, this very massive, mighty server, you know, this is a very, very strong server, right? This very massive, mighty server is used for only one thing. It used to only run, they set up the, what we call this Active Directory, which is a form of centralized authentication server, all right? So it's running the AD alone at the moment. So now, instead of now, Joe actually needs 4 more servers. Now, those 4 more servers, one, he needs to run an email server. On another one, he wants to run an application server. He wants to host Apache application on it. All right. Another one, he wants to host a Microsoft IIS application on it. Then on the fourth one, he wants to set up a Linux server for testing, as well as the AD. He doesn't want to bring down the AD. Don't forget that. He wants the AD to still be running. So he wants a total of 5 servers, right? Now, the requirements for the email server, it needs only 8 gig RAM. Okay, no, let's see, 16 gig RAM. Graphic, it doesn't really matter the graphic. 2 core processor and 500 gig RAM, storage for the mail server. I hope you guys are still with me. I know we're about to do some maths, but don't get confused. Just flow with it, flow with it. Okay. The Apache server requires the same thing, 16 gig RAM, but the Apache server requires okay, yeah, still okay, no, still requires only 1 core, still the same storage. The Microsoft server is the same exact thing as Apache. The Linux server, same exact thing as Apache, right? So now let's add the total, and then the Active Directory. Let's not forget the Active Directory, the current application or the service running on this big machine of a server. The Active Directory actually requires only 16 gig RAM and requires only 2 core processors and requires only 500 gig storage. Now let's add the 5 requirements together. Okay. So let's do a bit of math. So each of them wants 16 gig RAM. So that's 16 times 5 is what? I think that's about 60. I don't know if I'm correct, but I suspect I am. So they need a total of 60 gigabyte RAM. They need a total of one is a 1.52. They need a total of 2.5 terabyte storage. They need a total of how many core? So I have 1, 2, 3, 5, 7. They need a total of 7 cores processor. Please, guys, confirm you're still with me. I would know with your either your mute or you give us a bit of reaction or something. That's how I know if you're still with me. Thank you, Collins. Thank you. Good. Awesome. So now we've done our calculation. The 5 servers, what they need is not that if you give them more, you'll be very happy. It's like Oliver Twist asks for more. If you give him more, he'll be happy. Doesn't mean he's not satisfied, right? So if you give them more, no complaints, but they are what they want, right? What they need is what they require to work at optimal level. 5 of them would need a combined 60 gig RAM, 205 terabytes, 7 core processors. But unfortunately, what your company has is just one server, 512 gigabytes RAM, 16 core processors, and 5 terabyte storage. Now, this is where the trick comes in. Before virtualization, okay, before virtualization came, what you would have had to see and what you'd have experienced is you would have experienced 5 different people, 4 new servers with those requirements being bought. They would have had to go and, Joe would have had to go and made a request to buy a 16 gig RAM server for his mail, a 16 gig RAM server for his Apache application, a 16 gig RAM server for his Microsoft IIS application, a 16 gig RAM server for his Linux server testing environment. And he already has 512 gigabyte server wasting on his AD, Active Directory. Now, if one of those servers he bought, those extra 4 servers, if each of them cost $10,000, that's a total of $40,000 spent. And if we add the money that they used to buy the big server, which they spent $100,000 to buy, that's about $140,000 spent. This is on hardware alone. You would still spend some for licenses because this is an enterprise environment. You're not going to use free stuff. So you're going to pay for your licenses. So you pay for your IIS, you pay for the Microsoft, you pay for at least the Microsoft server and the mail server and the AD server, you pay for those. All right. So let's add the pay. Everything would be about 100 and let's say everything they paid for, depending on what you're using and the environment. Let's say everything sums up to $200,000, including software spend. Right? Let's put it at that back. Now, imagine we had virtualization. What virtualization would do for us is it would use that big, massive server that had 512 gig RAM, right? And it would create smaller virtual containers for each of the servers we need. So it creates a virtual container for the Active Directory. It creates a virtual container for the mail server, a virtual container for the Apache server, a virtual container for the Microsoft IIS, and a virtual container for the Linux testing server. Are you with me, guys? Ahanon, Joe, Collins, Nabi, are you guys with me?
Yes, we here.
Yes.
Awesome. Thank you. Thanks, Ahanon. Awesome. So now, Ahanon, I don't know if that's a question or just you confirming you're with me. Your hand's being raised, I mean. Okay, so I think it's just you confirming. All right. So now, as I said, with a virtualization software, you'll be able to create 5 smaller containers inside that big, massive server. So first things first, you wouldn't spend the extra 40K you are about to spend on servers. All you need to spend is you spend, let's say, 10K on the virtualization software license, add it to the original 100K that you bought the big server. Then for software, you spend about 20K because now, okay, so let me just put it, okay, so that's the Microsoft IIS, the Apache, yeah, so that's 3. Okay, so if you spend about, let's say, well, give or take, let's say 60, right? Let's even say 60K, let's say, or 50K. Now, against $200,000, your total spend would become $160,000. And this is the beauty of this total spend. The beauty of the total spend is, yes, you've spent $160,000, but you still have about 400 gig RAM left and about 9 core processor left and over 2 terabyte storage left to create more virtual machines. So meaning you would not need to buy a server and you'll be able to run like 10 to 15 virtual machine servers on that environment easily. quid pro quo. And this is because virtualization made that happen. This is one of the major importance and benefits of virtualization. It is helping you optimize your hardware and helping you save spend. And this is, let me just tell you a secret now, especially as you want to dive into this industry we are going into. In every organization, two things you need to understand. First, IT department is always seen as a spend unit. We are seen as the guys that incur cost. I'm not just saying this as a thing of experience. I'm not just saying it from a fact of, oh, it's what it is. I'm saying it from a fact that I have experienced it personally. Where I work, I know the kind of justification I make anytime I request for a spend. So IT units, technology units, cybersecurity units, we will always be seen as a spend. Whether we like it or we do not like it. It's like in our DNA, we are seen as the spenders, right? The guys that have a bit of leeway are the ones that build applications and innovate stuff that helps the business make more money. So those are the ones that say, oh, even though you're spending to help us make more. So those ones are given the leeway. But then see cybersecurity especially, ooh, they don't see the money we save for them. They only say, oh, cybersecurity have come again to ask for thousands of dollars. That's all they see. Because then they ask themselves, why am I spending this money? I have a very wonderful example. So, early, is it last year or, yeah, I think last year, the Central Bank of Nigeria released a framework for people they call OFI. They stand for Other Financial Institutions in Nigeria. So it's a law for Nigerian financial institutions. So they're saying that those that are not commercial banks and big banks, they fall within the range of the other financial institutions. So, and these, if you've ever stayed in Nigeria or know how the Nigerian financial market is, with the number of fintechs alone, the number of financial houses, number of investment companies, basically that sheer number, right, alone, you should know how massive and how many they are. I can tell for a fact that because I was opportune to actually present on the day they inaugurated the security guys of those companies, because the CBN did like an inauguration of all the CISOs of those OFIs. So I was opportune to present there, and I can tell you that they were not, a lot of them were not there, and I was seeing over 1,000 people, 1,000 different organizations being represented. There are thousands in Nigeria. Now, this is where I'm heading to this conversation. Now, the reason why CBN resists the framework is it was a cybersecurity framework, and just because CBN found that there was no regulation, no control, and there was no form of security adherence in that space. Only the top guys that have made a lot of money, like the big fintechs, like the Kudas, if you guys have heard of Kuda and the money points that were investing in cybersecurity because they had gotten to the level where they have so much users that they need to have some form of cybersecurity program. If not, they know that eventually, they will have a problem, right? So they have to. You understand? And it's having the regulation thing because they know they need to, and because of the size of the company. But the other small ones, the other organizations are just making things work. And if for those that have ever been in Nigeria, if you've ever been in Nigeria, the aspects of Nigeria, because we are talking about even the university microfinance banks. We're talking about even any microfinance bank that helps farmers in rural areas. They were all part of this. Now, all these guys have never thought or imagined about cybersecurity in their life. They've not even thought about what do they need it for. And the CBN put it there saying, you guys have to do this. Now, because of it was a regulation and was forced upon them, they all had to do it. But now this is the funny, tricky part. Now, I was reached out to help them perform this activity. Okay, oh, Kevin, we saw that you presented, the organization knows what to do. Come in and implement this for us. And, the generic figure, we charge is, let's say, $2,000 or $3,000 for such services. And then they were telling us things like, how can I charge $2,000 that someone is telling them to do for $300? Right? The message I'm trying to pass here is these guys really don't care about cybersecurity. In fact, the only reason why they're interested is because someone is about to force them to spend. So all they want is they're like, please do not stress me. That's basically they're saying, please don't stress us. Just come and collect these $300, give CBN what they want, let us go scot-free. They don't really care about if they're going to be secure. They don't really care about if they're going to be safe. They don't really care about what the repercussions of that will be. Right now, what I'm saying with this message is we are not seen as business drivers. We don't drive businesses. We support the business. So we support the business by ensuring the business doesn't get hacked. That's what we do. That's our own form of support to the business, right? So that is why I'm saying that if you are able to use virtualization to reduce your spend from $200,000 to $160,000 and tell the company that I have helped you save $40,000, I promise you they'll give you a raise because it will be magic for them. And that is how virtualization became a popular thing because everybody knew they needed to have it because it reduces spend massively. And it also helps you optimize your hardware. So it also reduces waste. So the virtualization has gone from a stage of, oh, it's a nice to have to, it's a must have in every enterprise environment. There is no enterprise environment that doesn't run some form of virtualization. I can beat my chest and tell you that. That you not come into any enterprise environment and you will not discover that they use some form of virtualization. It's almost impossible. No matter how little, they will use some form of virtualization, right? Even cloud computing is based off of the concept of virtualization. So this was just to illustrate the importance of virtualization. Okay? I don't know if that makes sense for us.
Yes, it does.
Awesome. Thank you. Thank you so much.
Yeah.
So
Can I
yes.
ask a question?
Oh, please go ahead.
So virtualization is a form of cloud computing?
No. Cloud computing is based off of the concept of virtualization.
Okay.
You get that? Yeah.
Yeah.
So exactly. So they create virtual resources for you. So it's the same concept that you work on. All right. So Ahanon, I don't know. Yeah, you're welcome. Ahanon, do you have a question? Ask the question. Okay, I think your hand is dropped off. Sorry. Just give me a few seconds. My lighting just needs to be touched up. Right. I think I'm back. Okay, so I'm worried I might not get to show you the demo of setting up a virtual machine, and the device in question might not last that long. Now, the next thing is there are something we call types of virtualization. There are types of virtualization existing. Now, virtualization comes in various forms, each of them catering for some specific aspects of IT infrastructure, right? Now, point is we can virtualize anything. We can create these are just types of virtual resources we can generate or create. So, example, we could set up server virtualization. That is, we could create virtualized servers. We could create virtualized desktop. We could create virtualization for application. On an application, create a virtualized container in it. We could also create a virtualized data, virtualized container for data. We could also have memory, just virtualized memories. We could also do virtualization at the operating system level. These are just different types of virtualizations, the main types of virtualizations, right? All of them trying to perform some form of virtualization at a certain level. Okay, good. Now, the benefits of virtualization to enterprises. I've already mentioned quite a few. I've mentioned already, I've already said reduce of cost. There's cost savings, there's resource utilization. I mentioned optimizing your hardware. Flexibility and scalability, very important. Able to scale up and scale down any resource. So for example, remember we gave our Active Directory 16 gig RAM, but then as we keep using it, we find out that it actually needs more than 16. And maybe it needs like a 22 or 24 gig RAM. You guys really just set it up and give it a 24 gig RAM. Very simple, just fine. Easily scalable because it's virtualized. If it's a hardware, we need to go and buy an extra RAM, open it, and plug it in. Right? So yeah, that's it. Then we also have it helps disaster recovery. Disaster recovery is recovering from disaster. So because of where virtualization works, those virtualized containers can be moved around from one location to another. So if you have the virtualized containers cloned to another location, you can easily recover that cloned instance, really. Also, things like improved management and automation, yes, improves the whole management of servers, makes it really easier. Rapid deployment of applications is also a very, very key aspect, because when you're setting up applications, your developers will need a very quick server to run some tests and to set up and just see it running live. Virtualization helps make that possible. Testing and development efficiency also very important. If you remember the 5 servers I said we're creating, one of the servers was our Linux test server, right? Then there's energy efficiency, also very, very important, because the amount of energy consumed by one appliance, one physical machine that is hosting 5 virtual machines is way less than the amount of energy consumed by 5 different virtual machines. All right. So yes, it's very important. Then legacy system support. It supports all forms of systems. Business continuity also relating to disaster recovery, and also allows us to do desktop virtualization. At the desktop level, you can actually create virtualized instances. Overall, virtualization is a fundamental technology for enterprises seeking to optimize their IT infrastructure, improve operational efficiency, and respond quickly to changing business needs. That is what virtualization can do. Now, let's just touch virtual machines. Now, virtual machines are the most common use of virtualization. Now, a virtual machine is a container of an emulated computing system that can run with its own entire operating system inside of it. So it's like as if you're seeing a brand new computer, but in a virtualized form. So you cannot put in your operating system if you want. You cannot put in your information, data, anything you want, like some bare metal computer. That's what virtual machines give you. All right. And this container includes all the hardware you need for a computer to run smoothly. Like you'll be able to put the virtualized RAM in there, be able to put video graphics in there, be able to put a network configuration, even the BIOS config in there, all in this virtualized container. Now, there are 2 common types of virtual machines. There is a system virtual machine and there is a processor virtual machine. Now, I want to quickly take this opportunity, now that I think my device is still up, to show you a typical example of what it would look like to perform a quick, or to show you what a VM could look like, virtual machine could look like. So I'm sharing another screen. I don't know if you can see it. Okay, I think it's, can you confirm you can see the screen sharing?
Not yet.
Really? The same has been shared here. Let's see if this will work again, please. Let's see. Task screen. Doesn't seem to be working. Yeah, this is the issues. I don't know if I'll be able to show this now. I've actually shared it here a couple of times, but I don't know why. Let me just see if I can do a quick reload. Just give me a few seconds. Let me see if it will work. Let me try. Do a quick reload and then share. So I'm actually trying to connect with another device. That's the one that I said is very, very low, so it might shut down anytime. So let's see. Let's see if I can show you the VM. Yeah, it wasn't able to share. It wasn't able to share. Yeah, I think I can be able to share right now. Yeah, it's unable to share, unfortunately. I think that there's an issue on the other system. That's not okay. Well, so I think we're going to have to move ahead, and I will show you the virtualization some other time, or during the project you would see it live and direct when you're giving detailed instructions. Okay. So okay. So I sorry guys, I think I'll just have to continue with the slides. The other machine is not actually allowing us to share our screen. It might have to do with it. So the other machine is a Linux machine, so it's a bit tricky sometimes, very picky most times. So I guess we just have to make do with what we have so far. You forget. You forget this. Okay. All right. So I'm going to share my screen again. Let me know when you can see this other screen. And then we'll take it off from there. Okay. Okay. Find it. All right. Okay, so confirm when the screen is showing so we can continue.
Not yet. Okay, it's on now.
All right, thank you. Okay, so yeah, as I was saying, so I wanted to show you a virtual machine, but then I think the other machine that I can set it up on, it's down. It's rejecting the Microsoft Teams. It's a Linux machine. So Linux operating systems can be very tricky. So in terms of sharing screen and stuff like that. So probably we'll have it another time, or when you do your project, you would actually see it. But then I think we could just continue with our conversation. And one of the things I was talking about is, you know, we remember when I was explaining the calculations and I mentioned virtualization software. And I said that this is a software that we can use to, what's the word? A software we can use to, what's the word we used? So that's the software we use to create the virtual machines we need. The 5 different virtual machines, you use that virtualization software, right? Now, to put a name to that virtualization software, it is called hypervisors. Hypervisors are the guys that allows us to handle the distribution of the various physical resources. The various physical resources to our required virtual resources. So these are the guys that helps us create virtual machines, helps us manage the virtual machines, helps us save them, shut them down, turn them back on, hibernate them, reduce and add whatever resources we need. The flexibility and scalability we mentioned that virtual machines could do, hypervisors help us achieve that. That is how important and key hypervisors are. Now, we have 2 distinct hypervisors. There is one we call the type 1, which is known as the bare metal hypervisor, because it runs directly on the physical machine. It functions as some form of operating system of its own. Some examples are Microsoft Hyper-V, VMware SXI, vSphere, Citrix. Now, what I mean by bare metal is it is a hypervisor that you can install on a empty computer. I don't know if anybody here has ever experienced buying a system that doesn't have Windows already installed on it. Has anybody experienced it?
No.
So you've not bought a system where there's no operating system on it.
No.
Oh, wow. You guys are missing. Well, if you have, you would understand what I mean by bare metal. A bare metal is an empty computer without no operating system running on it. So basically, it's just you and that operating and that system and that computer completely empty. Completely empty. So that hypervisor, or that type 1 hypervisor, is a type of hypervisor that runs on an empty computer, a bare metal machine. There is no operating system running on it. It's empty completely. So now, why am I reiterating the emptiness is empty, is empty, is empty? It's because this is the type of hypervisors we would see in big enterprises. Because big enterprises have massive servers, and the servers are bought not because they want to, the servers are bought just to drive virtualization. So you need to have virtualization environments. You get it. So these guys require bare metal hypervisors to make the whole process easy. Okay? Now we then have the ones we call type 2. Now, type 2, we also call them hosted hypervisor. Why? Because these are the ones that you can run on our computers, on our already running operating systems. So you can install it on Windows, you can install it on Mac OS, you can install it on Linux, whichever one. Did you get it? So that's why it's called hosted. You can install it on an already existing computer. That's with its OS and everything. And you can use it to create virtual machines, which is what I wanted to show us now before my system failed me. All right. So that is the type 2 hypervisor. So you can see that there is the type 1 and the type 2. And so depending on your need and your use case, you choose. However, it's very important to tell you that type 1 hypervisors are more efficient and faster than type 2 because, they are the bare operating system. The only difference now is to use a type 1 hypervisor might be a bit trickier than using a type 2 hypervisor because a type 2 hypervisor is designed to be used by anybody because it's designed to be put on, the architecture and design was to be put on hosted devices, devices that are already in use. So it's used for anybody. So it makes it really easy to use and really easy to understand. But the type 1 was built to be used by IT admins, experts. So to use type 1 is a bit right? So that is the difference between the type 1 and type 2 hypervisors. Okay? Hope you all agree with me. Hope you guys can still hear me. I'm still following.
Yes.
Thank you. All right. So back to our hypervisors. Now, okay. Now, then let's touch threats to virtual machines. What are the threats to virtual machines? Okay, I think I still have an hour, I can make it. So what are the threats to virtual machines? Now, there are a few vulnerabilities that are unique to virtual machines, to virtualization and virtualized environments alone. The 4 major threats are, there's one they call the VM escape, there's one they call data remnants, there's also one they call privilege migration, and the live VM migration. Let me just explain them step by step. Because of the fact that all of these virtual machines are hosted on the same hardware, because of that, there is usually some pathway from one virtual machine to another virtual machine. There's usually a way you can see another virtual machine resources. You can see what is actually inside the other virtual machine because they're on the same host, managed by the same hypervisor. So VM escape in this case, okay? VM escape in this case is talking about how can you more or less steal a virtual machine out of the hypervisor. So what that is let me explain. Let me put it in a much more detailed form. So with VM escape, we would be able to perform an exploit by running a code, all right, that would let the operating system of the, let's say, the base OS, the base OS of the operating system, you let it, what's the word? Okay, so let me put it this way. Trying to look for it. It's okay. Let me explain it this way. So recall that the virtual machines are managed by the hypervisor. The hypervisors are basically either it's a type 1 or it's a type 2. So if it's a type 1, meaning that the hypervisor is the base operating system itself. If it's a type 2, meaning that there is another base operating system. But the point is there is a hypervisor. Now, VM escape is, and remember, the hypervisors are the ones in direct communication of, they are the ones in direct communication and direct relationship and direct contact of the virtual machines. So with our example, when we first started, when we said that Joe's company have 5 virtual machines on one hardware, we're using a certain hypervisor. The type 1 hypervisor is what we used. Now, if I have access to one of the virtual machines, there's a code I can run on that virtual machine that would allow me to be able to communicate directly with the hypervisor. That is, I'll bypass the virtual machine and start communicating with the hypervisor directly. That is what VM escape is. Did that make sense?
Yes.
Good.
Yes.
Good. Exactly. So now the next one is data remnants. So this guy is a bit different. Now, what do I mean by why do I say it's different? So what he's trying to achieve, he's talking about what are the data that you left. Sorry, just give me a second. Let me, I think I might have to share. Sorry, because I'm trying to share. Can you also see my screen?
Yes.
Okay. Okay. I think it's back on my own side. All right. So as I was saying, data remnants is a way to, so as I mentioned, because of the way it works, hypervisors see everything. And recall, each virtual machine are doing a certain task. So each of them have their own data. Each of them are processing some data. There's a computing activity. They're generating data. They're saving the data, right? Now, because of how that works and the requirements and the whole back and forth on that guy, we can actually, there is a way you can manipulate one VM to be able to see the
I
data.
don't worry.
Hello? Okay. So I said there's a way you can manipulate the virtual machine to be able to see the data saved up in another virtual machine. So it's like some form of jumping, but you want to see what is saved inside another virtual machine. You see how tricky that is. So, because every virtual machine saves its data back into the virtualized storage by the hypervisor. So all you need to do is to manipulate it, communicate with the hypervisor, and start seeing the storage saved by other virtual machines. That is what data remnant is trying to say. It's a way of stealing data from other virtual machines. Now we have the likes of privilege migration. Now, privilege migration is about moving. So, okay, have I ever told you guys what it means to be a privileged user? Does anybody hear what it
Yes.
means to be? Okay, so you know what it means to be a privileged user.
Yeah. When you granted like an access to a system, right?
What type of access?
Like a password. You have your own unique password for system.
Eh, Yes, but like I'm talking about what when you say access, that what's the level of access? That's what I'm asking
The
about.
level, not like last week you were explaining like if Daryl .io like the CEO, you're
Mhm.
not giving full access to all the files on the system. You're giving just one particular access to what you alone can access. So,
Okay. Well, yes, I said that, but that wasn't what I was expecting to see. So, privileges, right? When I'm saying privileges actually mean administrator access, administrator control. You being the administrator, you being having the highest level of control. So you can, in fact, all those things where you're trying to install on your Windows machine and they tell you things like, kindly, either they'll ask you to log in as the admin, or if you are logged in as the admin already, they'll tell you to confirm you want to make this change. Only those with admin privileges can be able to do those things. So what privilege migration is saying is, if let's say we've been given privileges on one virtual machine, there are some manipulations we can do to create privilege on another virtual machine in the same hypervisor. That's what this is saying. And the live VM migration is stealing the snapshot of a virtual machine. These are some of the threats when relating virtual machines. Now, then we should then ask ourselves, what can we do to secure them? I'll start by explaining to you guys that here, virtual machines are the same as any other system. So what you do to secure normal systems is what you need to do to secure virtual machines. What do you do to secure normal systems? Well, for example, you should ensure those systems are updated, all the latest patches are installed, it doesn't have unnecessary services running, it's not connected to unnecessary applications or networks, all the basics, okay? But then, what the difference in this virtual machine is, for virtualization environments, the hypervisor is everything. If anything happens to the hypervisor, you're done. So what you need to do and what you need to take more care of is the hypervisor. Ensure the hypervisor is updated, ensure nobody connects to it without permission, give the hypervisor all the necessary requirements they need. Ensure the hypervisor has everything they need. It's very important. So if the hypervisor is safe, your virtual machine to a large extent is already safe. That's the message you're passing. Okay? Great. So that's one of the fastest ways to secure virtual machines. Ensure hypervisors are safe, ensure that there are not unnecessary pieces of software applications installed, and the rest of them. That is one of the sure bets in protecting hyper virtual machines and hypervisors. Do I have any questions so far? Because I want to jump to the next one, which is networks. Any questions so far? Hello? Yes, please. I don't think I got that question.
Okay, your screen was frozen for some time.
I actually removed, I stopped sharing. I stopped sharing my screen.
Okay, sorry. I want to ask. So,
Yeah.
so without the software, we can't create a virtual machine.
Without a hypervisor, no, you cannot.
Okay. Okay. So if you want to do demonstration, it means that we have to install the software first before we can do it on our own.
Yes, exactly.
Okay. Thank
That's
you.
exactly it. All right, welcome.
Thank you.
All right, thank you. You're welcome. Okay, so no other questions, I guess. All right, so let's jump into the next guy. The next one is we're going to touch what's it called? Let's see. So we are going into network, basic concepts of network. Okay, so I'm going to share my screen now and let me know when you can see it. I would try, this is where it starts getting tricky. And please bear with me. As I said, it starts getting tricky from here. So don't let it scare anybody. It's I'll put it this way, right? Networking on its own, is a full 3 to 6 months training. Just networking alone, it's a full 3 to 6 months training. So don't let I'm here to just teach you the basic fundamentals, because if we're going to discuss what's it called? If you're going to discuss cybersecurity, you need to have an understanding. basic understanding to a large extent of uh, networks. At least understand the concepts, the basic word and nomenclature, the basic core aspects of networks and networking. All right, right there. So let me know when you all can see my screen. Please confirm you can see the screen I am sharing. Okay, so the next thing we're going to do is we're going to work or talk about basic concepts of networking. Now, some of this we're talking about here is we introduce networking. We'll talk about TCP/IP model, the OSI model, some models and networks. We'll run through how understanding IP addresses, what that would look like. Talk about subnets and basic routing. And then we'll now touch on differences between VLANs and subnets. Then we'll now talking about some network devices, talk about network zones, talk about DNS, and just round it all off. All right, good. So please keep an open mind. You might get confused at some point if you've never talked about unknown networking before, but don't get worried. The more my advice, especially when we talk about networking, is follow the recommended learning. There are some points that guide you to a place where you can learn a lot about networking because you need to understand networking really well. So you can take your time and read up on networking. It would help. But then what I'm doing here today is giving you the foundations of networking, the basics of networking. All right. So networks is the connection of one or more computers for the purpose of communication. Built for communication. That's what network is here for. Now, networking, on the other hand, refers to the practice of connecting these computers and other devices to share resources and information. Networking is the practice of managing this network that has been created, or these networks we are talking about. That is networking. Okay. Now, it involves the use of hardware and software technologies, communication, and also data exchange between different devices within a network. That is what networking is really about. Networks and networking. So this is the easiest way to understand it and let it sink in. Networks, connection of one or more computers for communication. Networking, the practice of managing these connections and ensuring these connections are alive and effective and communication is happening. I don't know if that makes sense. Networks is connecting multiple computers together for communication. Networking is the practice of creating networks and managing networks. Simply put. Do you get it? Yeah, you get it. So that is how we can understand that. Okay, so I'm seeing Ahanon's question now. Ahanon, sorry, I'm just seeing the question. So to answer your question, you can get it. You can install and download a VMware and set it up anyway. In the project for this course, one of the things you need to do is to set up a virtual machine, and there's a detailed instruction on how to get it. You get, so I think there you can get it. But then if at that moment you still want to find it out on your own, you can also reach out to me on Slack and then I'll guide you. All right? Good. Thank you. Okay, so back to our networks and networking. So then we'll now talk about two network models. Now, these models are like a representation. It's like a logical representation of how tasks are managed and organized in a hierarchical form in networks. So he's saying that for networking to happen, two things. Remember, there are two important things I said in networking. One, networks are connection of one or more computers. That's one. For the purpose of communication, that's two. So connecting them is not enough. They must be able to communicate through that connection you've created, right? So this network model is giving you a logical separation of tasks that enables that communication between the computers. Now, it helps us understand how the flow of data is transmitted, converted, and used or communicated through the network. Now, there are two network models we'll touch, and basically there are two network models anyway, which is the OSI model and the TCP/IP model. Now the OSI model. The OSI model is split into seven. My bad. Split into 7 layers, right? Now this 7 layers shows also talks about what are the responsibilities and what is the responsibility at each layer and how can we get the best out of each layer and how is the data going to move from sender to receiver. The first layer is what we call the physical layer. Who can tell me why it's called physical layer?
Because you can feel it and see it.
Exactly. You can feel it and see it. Thank you. That is why it is called and referred to as physical layer. Now, on this physical layer, all right, what happens is data is transmitted as a bit stream. That is, it's transmitted in the form of ones and zeros over the physical medium, that is, over the cables plugged between the two computers. So physical layer describes what happens or explains the task of moving that data physically through the physical world. I remember I said there's always a hardware aspect of everything in IT. So this is one explanation. Okay. Now the data link layer is the next layer, and this one helps to define the format that data on the network goes. That is, what is the format that data in the lowest level is going to go? So from that physical layer, how is it going to communicate and send from one computer to others? What's the computer going to see? And what is the computer going to understand it? And so it sends its data in the work in frames, in what we call frames. It sends its data out in what we call frames. And data link layer is at this layer, layer 2, is where devices that are connected to each other understand each other, right? So they call it the layer 2. That's what they say. It's like there is a closer bond, not too much changes. So it's on this layer 2 that they have what they call MAC addresses. Now, who here knows what a MAC address is? Let me just put it out to the class if anybody has ever heard about MAC addresses before. Anybody ever heard about MAC addresses before?
I've heard
Okay, what
about
do you know
it
about
before.
it? What do you know
Okay,
about it?
MAC means media access.
Mm-hmm.
I can't remember what it stands for, but usually from the manufacturer.
Beautiful, thank you. Yeah, that
It's
was
on the hardware.
perfect. Exactly, that was perfect. Yes, it stands for media access control, and yes, it is from the manufacturer. It is a permanent number that is burnt in to the computer. So anytime that computer, every computer or any computing device has it. There's any computing device that can connect to networks has it. Now, anytime that computing device connects to network, any form of network, both physical and wireless network, all right, that MAC address is what is used to identify that device. And this MAC address is identified on the layer 2 level, which is the data link layer according to OSI model. Now, the next layer is what we call the network layer. Now, this guy is where the intelligence in moving a network and in communicating on the network comes into play. This guy is one that decides how the data would go. What path would the data take when it's going? That is what this network layer decides. And what are the things in the network layers um, 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 task or level? Firstly, network layers, as they said, layer 3, they use what we call IP addresses to recognize different devices. Now, IP addresses is the way every device on the network or internet communicates to each other. You cannot be on the internet or you cannot be on the network without having an IP address. Everyone must have an IP address. Everyone. So that is the first thing that you get from layer 3, IP addressing, helping us with the existence of IP address. IP address and IP address routing and IP address decision making starts at that level. The devices, network devices can see playing at this level is routers. Routers can work at this level. Okay. Now, moving on. We then jump to the transport layer. Now, as the name says, its importance and its value is to transport from one location to another. Now, its focus, this layer 4, is the one that is thinking about the task of transmitting data using some transmission protocols. So what is the protocol at which this data would move from here, position A to position B? It's a transport layer that thinks about it. Okay. Now, the transport layer uses two transmission protocols called TCP and UDP. Now, I would have loved to talk a lot about them, but don't worry, we'll get to them later on during the program. But just know that they are the two major protocols that works in this transport layer. Then we then have the session layer. Now, in session layer, we would see and would notice that this is where connections happen. When I say connections, what do I mean? So let me put it this way. We want to, okay. Has anybody ever noticed this? I don't know about those outside the country, but I'm talking out of experience with some of the mobile banking applications in Nigeria. I know when I try to perform a transaction, whenever I'm doing a perform transaction, and I leave that app and I don't close, like I don't log out. After like a few minutes, I see a notification saying you have been logged out due to inactivity. Has anybody ever experienced that before? Your session has been cancelled due to inactivity. Has anybody ever experienced that before?
Yes, especially with the banking apps, it locks you out.
Exactly. Exactly that. It logs you out. So yes, so that's exactly one of the things I'm trying to explain. So in that way or in that mode, right? What we would be doing, or what it is detecting, or that thing that it looked at and said, oh, that thing looked at and said, oh, you are meant to, or that thing looked at and say, oh, you are actually inactive for a while. That thing it looked at and made that justification that you're actually inactive is what we refer to as a session. Now, a session maintains the connection between you and the receiver. So, I wish I can do a very, very quick, have a very quick whiteboard to do a quick diagram here. Let me see if I can. Let me try. Let me just quickly try see if I can do that here. Can you see this with this Word document screen I'm showing you?
Yes.
All right, great. So this is what I want to talk about. Now, if you have, let's say this is Kevin's system, Kevin's phone, trying to communicate with the banking server, with the banking app, right? I log in. By the time I log in, before I want to log in, there is a connection initiated. I will call a session opened between my phone and the banking app. Now that session, that trend, I can do better. Now that drawing, that session, sorry, not drawing, that session opens that communication, opens the communication between these two ports here. even though this wireless connection, but it initiates that connection, saying, allowing me communicate with the banking app. So every communication I have at that moment is through inside this session. All right. Now, the moment this session remains inactive for 5-10 minutes, these guys will say, oh, you know what? It's like this person is no longer using it. It kills the session. And that's when you now see that, you have been logged out due to inactivity. Now, the question you should ask me is, why do they always kill it? Let me explain why. Now, imagine you and I, imagine you log in, right? And then you leave it. Now, because of how it works, this session stays open, waiting for traffic and waiting for connection. Now, if you log in, you don't log out, but you just maybe minimize and go and do something else on your phone, this session still stays open, even though you that have left that app don't know it. Over the network, this session is existing, right? Now, what happens is if you have a hacker, so I'm going to draw a very wonderful diagram from a hacker. Sorry, I used to be one of the best artists when I was in school, so sorry. My diagram can be very beautiful. Anyways, so point is, I have a hacker that is currently monitoring me. He's watching everything I'm doing. Now, if he now notices that I initiated a connection to my banking app, and I didn't log out, he can hijack this session. Once he hijacks it, every communication is now between him and the banking app. However, he's communicating on the session you created. So meaning that he's communicating as you with your login. So you logged in, you left your login there. So you are still logged in on this session. So he just taps into the session and is now communicating with the app as you. So he can perform transactions as you. This attack is what we call session hijacking. So that's the reason why you see those bank apps after 5 minutes or thereabout, they'll just say, due to inactivity, they'll cancel your session for you. Then you have to log back in. You don't have to log back in. You get it? Are you guys with me? Does it make sense, guys?
Sorry, I can't see the screen.
Oh, really? Are you the only one that can't see the screen? Others, can you see the screen? I'm sharing a Windows document. Can any other person see it? Oh, it just
Yes,
became.
I can see it. I can see it.
Oh, okay.
I can see it.
Okay. Also. Thank you, guys. So, Nabi, maybe it might be your network that just glitched on your side. Okay. But the explanation I did it add up? Did it make sense? Did you understand what sessions do now? Do you understand sessions? Do you understand sessions?
Yes. Yes.
Awesome.
Yeah, sure.
Thank you. So,
Yes.
all right. Thanks, guys. So, going back to our slide, there are still some other layers we've not touched. Like we have the presentation layer. Now, this presentation layer is the guy that helps convert our data to a format that we can use. So it's at this layer that things like data encryption would happen. Is at this layer that things like our data format is going to set up. Basically, that's here that a lot of things are going to happen. But it's this layer that formatting would most likely happen. Now, on the application layer is the one we call the human-computer interaction layer, where applications can access the network services, where we can use our email, our Outlook email, to send mails over the network, where we can use our browsers to browse over the network. It's on this application layer that it's determined. All right. So what at the presentation layer is where the formatting of the data or the communication of the traffic is done. Yeah, maybe it will be need to change our data to maybe HTML for it to be able to build on a browser or to an Outlook file for to send it via email or send it via email. You know, all those things happen there in those levels. Okay. All right. So that's that for the OSI model. Now, a few things you might want to learn and I want to not forget. So there are some things you might forget. For example, MAC addresses work on the layer 2, which is data link layer. IP addresses function on their layer 3, which is network layer. Transport protocols like TCP, UDP are on the layer 4. Network ports actually happen on layer 4 and 5. You might not forget these things. It might help. Okay? Good. Let's move on. Oh, beautiful. Good question, Ahanu. Now, the thing about sessions is the session is created already. So at that moment you create the session, you are using it. The hacker cannot hijack it. So he cannot just hijack because you are already using it. So it is when it is inactive that he hijacks. Because so for example, you are performing some activities, performing this, performing that. So there's a constant communication. The most he can do is if he's seen everything, he can be eavesdropping. He can be eavesdropping, seeing what you're doing. But he can't take it from you because you are currently using it. So the minute you now leave it inactive, he will then hijack it. That's how it works. All right? Great. Okay. All right, thanks. So it seems like I left the call. I might have not really clicked the leave button, sorry. But yeah, can you share my screen again? Let me know when you can see it. So can you see my screen again? Share it again. Can you just react with the thumbs up or something? Hello, can we all see my screen?
No.
Oh, really? You can't see it? Shared it a while ago.
Yes, it is.
Okay, thank you.
Yeah, yes.
All right. Thanks. Okay, so as I was saying, I was talking about this PIP model that is a bit more concise. It's like it punches and squeezes all those different layers together into one, you know, to make it usable. I guess that's the best word to use right now. Now, the different application, the different layers in this model shows. So I've mentioned that the internet layer is still the same as network layer. The transport layer now combines the session layer and the transport layer into one. The application layer combines the presentation and the application into one. All right. But the network layer still stays the same. That's to tell you that a lot of things happen on that network layer. And that's why it's called networking. There are a lot of things you need to do and would need to do and ensure set up right on that network layer. Right? But then point is, this is what the TCP/IP model looks like. It is a smaller version of the OSI model. So the OSI model is 7 different layers. This one is just 4 different layers. So it's just simplified version of OSI. All right? Good. So if you move on, let's now talk about IP address. What is an IP address? Now I've been talking about IP addresses. Now there is no device connected to the network that doesn't have some form of IP address. That's not telling you. As long as it has hit the network, even the first second, an IP address has been assigned to him everywhere. All right. So that an IP address is a numerical label assigned to every device connected to a computer network. For you to be on a computer network, there must be an IP address you have assigned to you. So these IP addresses serve two primary functions. One, it is host or network interface identification. It's a way for us to identify you. And secondly, location address. Oh, sorry about that, guys. Sorry. Just didn't get my coffee this evening. So, as I said, IP addresses serve two main functions. One, a way for you to identify the device or the network interface. The second one is location addressing. That is, address the location that you are in. That is what IP addresses call. Okay. So now there are two types. There's the version 4 and version 6. Version 4 is the one that everybody might have already experienced. I'm pretty sure seeing something like 192.168.0.1 is not a surprise to people here. I'm certain we have seen a figure like that since we've been using computers, haven't we? Guys, have we not?
Yes. Yes.
Good. IPv4 is the widely used type. It's the one that's been in use from the moment the whole networking and IP addresses came into play. Right? So it is the version 4 that everybody uses. However, we've seen that because of the growing number of assets or devices in our internet world, we are now having what we call IPv6. IPv6 is now in use or in produce or in work. Basically, people are using it. But IPv6 is not as easy as IPv4. It's a bit confusing. You can see the way the IP address looks, 2001:0DB8. There's nobody that remembers it. So that is the difference between IPv4 and IPv6. The IPv6 is in use, but very scantily, meaning that a lot of people prefer to use IPv4 if they can help it. IPv6 is now enabled in almost any network. So in case there's need for an IPv6, we easily just switch, configure, and we're good to go. All right, good. Now, moving on. Now talk about routing. We're talking about IP addresses, but we're not talking about routing. What is routing? Routing in networking refers to the process of directing data packets, deciding the direction and where data packets would go, and how data packets will move from one network to another. So when devices need to communicate across different networks, routing and routers would help them play a crucial role in determining the most efficient way of the cyber data. So what it's doing is, what's the most efficient way for cyber data to move from one place to another? That is what routing is. If you recall OSI model, we mentioned that networks is where we agree that, okay, it's a network, we said that it is deciding the physical parts, the data traffic, network data traffic would go. That's routing, deciding how that connection would happen. All right, that's routing. Now, some key points about routing you might not want to forget is: one, interconnecting networks. Routing and routers is essential when devices on one network is trying to go from one network to another. So when devices on one network says, you know what, we need to communicate. We need to communicate with each other. We need to share and transfer network data from one person to another. Routing is essential, especially when there are multiple networks. Remember, I'm pretty sure I talked about internet last week, and I said that internet is an internetwork of things. So routing is the one that enables the networks to connect to each other. All right. There are a lot of things about routing that are here, which you can read upon later. There's things like routing table, which is what routers use to be able to they configure to be able to use and be pushing traffic and network traffic to where it's meant to be. We have things like decision making that routers perform. Routers are also performing things like dynamic and static routing. Routers have routing protocols, packet forwarding, path selection, and you can perform subnetting through routing. Now, the next is subnets. I need to touch on malwares before we round off, so I'm just going to speed up just a bit, a teeny bit. So the next is subnets. Now, subnets, which is a short form for subnetworks, is a logical subdivision of an IP network. So for example, you're given an IP network. I said, this thing it's a way to just reduce them smaller, logically split them into smaller networks. And all network devices, especially routing and firewall devices, understand the subnet process. And so when a subnet is done, configured, and put in, every device understands the message when they see a subnet and it's masked. They know what's expected and they know how to handle it. And they know how to redirect when needed. All right? That's subnets for you. And that's the importance of subnets. Now, subnet has several benefits it provides us. One, efficient IP address utilization. It also gives us improved network performance, very true. Enhanced security, yes, because you're able to segregate your network effectively, which is segmentation I've been talking about for quite a while. And then simplified network management as well. These are some of the things that you need to look at. All right, so let's move on. We then have what we call VLANs. Now, we've already spoken about subnets. They are logical separations. We then have VLANs. It's also some form of logical segmentation, but this is the difference between VLANs and network. A network logically splits and creates smaller networks in an IP network. But a VLAN is trying to logically segment a physical network. They're saying this network, we are plugged to one place, but I want to logically split it into smaller spaces, smaller different networks that they will be seen as completely siloed different networks. Completely. Guys, sorry, I don't know why it cut me out of the call again. The second time this is happening. It just basically cuts me out. Well, we're actually rounding off. We're rounding off very soon, guys. So just please bear with me. Bear with me. Let's discuss this final thing in networks, and then I'll then teach you a bit about malware, which I know might get a lot of people excited, and then round off today's session. All right, hope that's cool. All right, confirm you can see the screen I'm sharing. I'm sharing the difference between subnets and VLANs again. Confirm you can see that. Can we see it? Can we see that screen? Hello.
Yes.
Yes,
Yes.
I can see.
Thank you. Thank you. Okay, so
Welcome.
yeah, so to just quickly round off what I was saying about subnets and VLANs, there are a lot we can talk about. You can read it up, and then we would get to do the project and the hands-on project, and you get to see how it actually works and get that experience. Okay, then we can talk a lot about networks, because what I need you to understand is the foundations behind networks. I need you to understand the OSI models very well. I need to also understand the network devices like switching, routers, and the rest. You need to understand what they do. For example, routers, we already said that routers are helping to route and dictate the direction that the network goes. And it works just like that. And switches are the guys that connect devices in one network together. And they work on layer 2. Those are the kind of things you need to understand. Because when we talk about cybersecurity and relate it to network security, the thing you need to hear is, what do the switches do? What didn't they do? What did the network devices do? What didn't they do? That's the kind of conversation we are going to have. All right? Great. So then, okay, so I mentioned network devices. Then I wanted to round up with network zones. Now, one of these that you get, and then you see, when people ask and say, what can they do to make their network secure? And I say there are a lot of things they can do, right? One of the things I always don't forget, I always try to drive down. One of the messages I always try my best to reiterate is zoning, network zones, network zoning. Network zoning is very important. It is so important. Do you know why? Because we cannot hack what we cannot reach. So if you put your network zoning properly and you segment your network effectively, nobody will be able to hack you. Or at least, even if they do, it takes a lot of work, like a lot of jumping and jumping. And I don't know if I mentioned this in the last class, but I think you should have. But there's no 100% security. So our work is to make our environment so resilient to an attack. So if an attacker keeps on jumping, and trying to hack, goes here, just to attack us, meaning that we are doing a very good job. And so that's why I wanted to round off networking with network zones. That is why network zones are very important. And then there are 3 major zones in network. And then they can put in smaller ones and either create sub zones and stuff like that. The 3 major zones are LAN, WAN, and DMZ. LAN is talking about local area network. WAN, wide area network. DMZ, the military zones. LAN is our internal network. They are the guys we know, the guys we trust. WAN is the internet, the guys you don't trust. Then the militarized zone is any of our internal resources that we want to have access, or we want people in the internet to have access to. We put it in the demilitarized zone, which is called the DMZ. So for example, if we have an application that all the general public is using, we'll put it in the DMZ because it is our own internal resource, but we want people to have access to it. Do you get it? So yeah, that's how one of the things you can talk about when we talk about networks and networking. Do we have any questions so far? So this is not part of our quiz, because we'll still get a quiz from the platform, but I'm giving you all an assignment. I hope you all can hear me.
Yes.
Can you all hear me? Good.
Yes,
The
we can.
assignment is for you all to go and research on what is meant by a DNS, domain name system. Read up on it, research on it, and write. I don't want you to even write anything. Just read up on DNSs, research on it, and then in our next class, I want each and every one of you to break down the importance of DNS too. That's all. That's all I want you to do. DNS, domain name system. Please, our next class, that's where we're starting from. I want you just to break down what is the importance, why is DNS so important? All right. Okay. So last thing we'll talk about today is malware. I wanted to introduce malicious software to you. So I'll just quickly do that and take 10 minutes. It wouldn't take long. I wouldn't I'll try to not stretch it, other than sharing the examples, the types, and what you can do, and then we can then open it up for questions. Okay. All right. So I'll share my screen again. Let me know when you can see it.
Yeah, we can see it.
Awesome. Awesome. So I want to introduce malwares. In our last few minutes, we'll just talk about malwares. First of all, let's define malware very briefly. Malware stands for malicious software. It's in the barest minimum, in the simplest form, it is any software that is designed to disrupt or damage a computer system. That is a malware. As long as you've been built to cause damage to a computer system, you are a malware. That's what's called malicious software. Simply put. Okay? Now, this software is usually used by cyber criminals and hackers. And they use it to do what? To steal data and damage the computer's network. All right? Now, there are different types of malwares, but then there are some that are quite important. For example, we have the ones we call viruses. These viruses are the oldest form of malware there is. These guys are a malicious code. They're able to run without the knowledge of the user. What do I mean? So a virus is able to run in a computer without the user's knowledge, without the user's know of what's going on. And then it can now cause either slowness of the computer, it can either corrupt some devices, it can either mess around with a few software packages. All right? But it is an application or a malicious application that is able to cause harm. Simply is able to cause harm to a computer without the user's knowledge. Okay? Now, the thing here is viruses can move around your network. That's why they're scary. They can jump from one device to another, from one device to another, and go throughout your entire network the way a virus would in real life. That's why it was given the name virus. It can jump around the way a virus would in real life, but then it must be contracted or contaminated or transmitted to you. So as long as it's on your network and you are performing the activities you want to perform, for example, you are copying something or you are clicking something or you are sharing something, that virus is jumping from one place to another on your network. Then there are different categories of viruses, boot sector virus that hits the computer at the booting stage, quite a different number of viruses. All right, but we don't go deep into that right now. Then the next malware we are talking about here is worms. Now, worms are also another form of virus, but the difference is a worm can replicate and spread through the network without our user performing any activity. Virus is saying it will move laterally. It will move from one device to another on your network. But then, someone must do something. Someone must like click something, send something, open something. But worms don't need you to do anything. The moment a worm is inside, you just keep trying to jump to another device. You don't try to hack more and keep jumping and keep. It's just what they were built for. That's worms. Then we also have Trojan horse. We also have ransomware. Who here has ever heard of the story of Troy?
I have.
And you remember how the land of Troy got defeated, where they allowed a certain horse come in, thinking it was from the gods. That's the same story for a Trojan horse.
Yes.
It is a device or an application that looks good, looks safe, calling you to use it, only for you to find out later on after he's done with you that, I've hacked what I want to hack. I have taken control of what I want to take control of. I don't need to be here anymore. But when you brought him in, he looked so good. No problem. He's here for a good thing. No problem. He's not causing any issues. By the time he's done hacking you, he says, "Oh, yeah, I'm done with you. I can do whatever I want to do now." That's the idea of a Trojan horse. Coming, this being deceitful, you allow him and give more access he needs, and you're done for. The next thing is ransomware. A ransomware is one of the most used types of malware out there. The ransomware is just any malicious software that has the capability to keep your data as ransom. How will I do that? I would encrypt it and tell you, bro, you cannot get this data unless I give you the decryption key. Are you with me, guys? Waiting to get that feedback.
Yes.
Awesome. So that's a ransomware. Ransomware can cause that problem. In fact, ransomware has caused a lot of problems in our industry. You get it? So it's also another major type of malware. Now, the thing about ransomware, the message I pass about ransomware before we even leave here is, no matter what happens to you, no matter the ransom or malware attack you experience, especially ransomware attack, never pay the hackers. If you have a ransomware attack and they say, "Oh, your data is stuck, you have to pay," I'm telling you this now, never pay them, because they will come back again, or they will not even give you access back. Never pay them. Never pay them. All right? Good. Now, next thing we'll touch is malware infections. Malware infections. Okay? Now, malware does not just appear from nowhere. I like saying that. If you have a virus, you'll be like, I have a virus. It didn't just happen overnight. You didn't just wake up and had a virus, right? It came from somewhere. You were infected by something, right? And that is what malware infection is talking about. He's saying that he's trying to tell you that you were infected somewhere. And there are two pieces of information that you might need to know when talking about that. One, either it's through a threat vector or you find out what the attack vector is. The threat vector is how did they get into the machine? That's how did they reach? How was the attacker or the virus or the malware even able to reach as in network via the network? How was it through network able to touch or be able to reach or be able to jump to that machine that you have infected? That's the first thing you need. That's the first question you need to ask. How did you get here, sir? Did you use bike? Did you use a bus? Did you fly? How exactly did you get here? That's the first question. The second question is, when you finally got here, how did you install this malware? How did this malware install successfully? That's the second question. So malware infections, how did you get here? And how did you eventually install these things? So these are some of the things you might need to want to know when we talk about malware infections. Good. Now, some of the common delivery methods of this malware are one, from software, that's from an application. Two, through messages, emails, instant messaging, chats, WhatsApp. Three, through media, USB drives, CD, and the rest of them. Four, through what we call a watering hole. A watering hole is where people go over and over and over again. Now, if you go there and listen or plan stuff, maybe put a flash drive there, because people would always keep visiting that place. Your hope is that their constant visit of that place, you would use it to entice them to do something wrong or drop something for them to put in their system. But that is what a watering hole is. It's one of the ways people can get malware infected. The next one and the last one I'll talk about in malware infections is typo squatting. Typo squatting is cloning a well-known popular site that you know you would certainly be in or be into or want to connect to, right? And then once you connect, but then you are connecting to the malicious version. Once you hit that fake website. So it looks real. That's the thing. The fake website looks very real. And that's called typo squatting. It looks very real and very believable. But then it can make people connect because they trust or they think that that is the legit, that's the legit, what's it called? That's the legit website. No, it's fake. And that's why it's called typo squatting. Now, how can we prevent this malware? There are a lot of things we can do. One of them is have a very, very good antivirus or anti-malware software, like Windows Defender, McAfee, Norton. Another thing is constant updates and patches is very important because that's one of the ways that this malicious software actually needs to take advantage. Host-based firewall is also something you can consider, but another thing we could do is ensure we have anti-malware systems or solutions to help detect worms, ransomware, trojans, and the rest of them. Also, our web browser security settings must be set to a non-trusted method is also another way. But then I want to summarize this and I want to round off because we're already behind time and I don't want to take more of the time. There are three core things that we need to have in the back of our mind when we think about how can we prevent ourselves from a malicious software attack. One, please, updates is like one of the easiest and one of the most powerful reasons why we keep having these attacks. Ensure everything is updated. Every line is updated. Ensure everything is right. So that is one of the first important things. Everything must be updated. Everything must be updated. I don't know how else to emphasize how much everything must be updated, because I can tell you for a fact that I know I have led that this might be right. Hope I can still be heard. So I'm saying that everything must be updated, whether we like it or not. Always update everything. It's key. Okay. Another thing is, so update your operating system, update the patches, everything you have, even your antivirus systems antivirus malware should be updated, and then use it to regularly, schedulely scan all your computers. And last but not the least, I don't know if I've mentioned this before, but please train your users. I think I did in the last class when I was explaining to you how user training is one of the most important admin controls that there is. So now we are retracing that point. Train your staff. We've seen there are scenarios, there are organizations that they've reduced their risk landscape by over 20% because they rigorously, not just trained, they rigorously trained their staff about security awareness. So I don't know if we have any questions so far, because this is where we will stop for today. So guys, do we have any questions?
It's clear.
It's clear. Wonderful. Good. So now I think what I want us to do, and what I want to start happening is I need you guys to start looking at the project, because I want you guys to start it, so that by the time we haven't joined in our next class, some people might have already tried some things. If we hit some issues, we can come. I can see if I can help and show us a few things, to guide us on this project. But I think we need to start doing those projects now, especially for this first course, introduction cybersecurity course. We need to do those hands-on that are there. You set up your VM, you would do a quick network setup and design and stuff like that. So yeah, I think we need to do that as soon as possible. Okay. So yes. Yes,
Where
please.
will we find that?
Yes, Joe, you have a question.
So
as I mentioned, the project, as I mentioned, I said I'll reach out to your training coordinators to ask where it is, and if not, I'm pretty sure they'll share with you. Same as the quizzes as well, and the curriculum that you asked for. Okay. Osadono. I don't know. I don't want to pronounce any wrongly. You raise your hand.
Okay. Yeah. Good evening, sir. Yeah, that is Sadolo Befun.
Okay. Good evening.
The class actually indeed is interesting, and I just joined the class new. I just want to ask,
last week.
yes. So please, I want how I can get the recorded video class so that I will follow up last week and even today. Okay.
Yeah, that's not a problem. So on the have you been added to the Slack group?
Slack group.
Slack channel.
Slack no, I don't think so.
Okay, I would bring it to the attention of the team, and I'll tell them that you need to be added. So because the moment you're added, I think they'll give you the links to the past recordings and everything.
Okay, sir. I'll be grateful, sir. Okay,
all right. Thank you.
Sorry, he has been added.
Yes,
I can see him. Hello,
oh,
he has been added.
Okay.
Yes, I can see. I can see the message on Slack.
Okay, that means what just happened. Like, okay,
just to forward the link to him.
Yeah, just forward the link to him. All right. So I think
Thank you, sir.
Thanks, Collins. Okay, yes, I saw he's just added here. So you just mentioned that you need the link and it gets to you. All right, thank you. Okay, guys. So any other question? Nabi, Joe, Ahanon, Charles, You have anything to add?
So how soon will we get a response about the project?
So for the project, okay, so I'm actually right now trying to text, reach out to the training coordinators to actually, get you the access to those things.
Okay, so the link will be shared to us on Slack, right?
Yes. We use Slack.
Okay. Thank you, Kevin.
All right.
Thank you so much.
Thanks, guys. All right, then.
Thank you, Kevin.
Thank you. All right.
Thank
you
you
so much, guys. Thank you. So I really hope for our next session. Hopefully, I think the next session is meant to be about training systems, if I'm mistaken, but whatever it is, we'll actually work on it together. Now my advice, there is usually what we call recommended learning, where you see some pointers, some things you can actually go and read on your own. My advice is when you have access to recommended learning, please read up on your own, because then you'll be coming back to our next class with a lot of questions, right? Okay, oh, I saw this. What does this mean? Oh, I read up this. What does this mean? Oh, it's so by the time you read up that as well, do your projects, attend the live classes, all those pieces of knowledge will keep bringing it together and just enforce what we are learning. That's the whole idea. That's the way. That's the IOV. All right. So it's to invest in yourself. Do the projects, do the reading, attend the classes. All those pieces of knowledges would come together and enforce a very strong knowledge. All right. All right, guys. So I highly recommend the reading for networks as well, because we basically just brush the surface of networks. Also, don't forget your assignment, DNS. Please don't forget it. I'll remember the next class. DNS, very important. All right. Okay, then. Thank you so much, everybody. Thank you all for joining. Really appreciate it. Really appreciate how interactive you guys were. And I hope to see you in our next class. Have a great day, guys. Thank you.
You too, and have a good week, okay?
Yes, you too. Thank you.
Thank you, sir. We are grateful.
All right, me too. Thank you, guys.